Okay, you ready?
I guess so.
Boom. Check it out.
That's tiny.
Well, I mean, yeah, that's what everyone says when they first see it, but it can actually do a lot.
I don't know about that.
Are you kidding me? This thing's got a quad-core ARM-based processor clocked at 1 gigahertz, 512 megabytes of RAM, full Wi-Fi, full GPIO, 40-pin layout, and only pulls like 1 watt. It's freaking crazy. Oh. Well, I think it's cool, so yeah. So like the title of the video states, we're going to be turning this Raspberry Pi 02 into a server, effectively making it the world's smallest home server, totally verified by Guinness, 100%. Don't fact check me. Now, before we get started, let me make one thing clear. If you're expecting me to pull some kind of magic out of my ass that's going to make this thing go head-to-head with a full-fledged AMD EPYC-based system with 64 cores and a terabyte of RAM, then I'll have some of whatever you're smoking. The idea here is to have a cheap, low-power device and turn it into a quick, portable, capable way to run or test some of your home lab services. Now to get started, we will be flashing our SD card with Raspberry Pi Lite as we won't be needing a desktop environment. There have been some major upgrades to the official Raspberry Pi imager that make this experience much better by letting us set up Wi-Fi, SSH, and credentials all from within the imager. Neat. This way, we don't have to worry about modifying config files manually, or even worse, hooking up a keyboard, monitor, and mouse. Blech. Of course, you can choose to install the desktop environment if you have services that require it, or if, you just want to do it. It's your hardware. In my case, we'll be using Docker for everything, which doesn't really require us to have a desktop environment, so we don't have to allocate any resources to it. And resources are pretty slim pickings on the Raspberry Pi Zeros. The Pi 02 has a micro USB input that you could use for whatever expansion you see fit. Note that it is limited to USB 2.0 speed, so don't expect a ton of bandwidth. For my little server, I purchased a micro USB to USB Type-A adapter, which will let me connect an equally tiny external storage solution. I'll leave it to you to decide how you want to use this port, whether that's for storage, networking, foreplay, peripherals, whatever. So obviously the first step in getting our Pi Zero to start pulling its weight is to get Docker installed. Well, the first step is actually to SSH into our tiny boys, so let's do that. All right, here I am in Windows 10, and we will be using PowerShell to SSH in. If you're using Mac or Linux, then you can just use a terminal. We're going to go SSH. We will be using the default Pi user. And the hostname that we provided when we were installing Linux to our SD card was pi0.local. It's asking for a password. You'll never guess it. And boom, we are in. Now, once you're in, the first step is to get Docker installed. Now, I've done this so many times on all my other videos, and honestly, it's already running, but I will show you the steps you have to run through. It's literally like 5 lines, and it will be linked down in the description. So it's on the official Docker website. First thing you do is run an update, install some prerequisites, add the official GPG key, set the repository, and then literally update and install Docker. It's what, 1, 2, 3, 4, 6 lines. So you can do it. Now I'm using Portainer to run all my stuff. It's very common on a lot of my systems. You don't have to use Portainer. You can stick to vanilla Docker CLI if you're a hardcore beast, but I'm just a baby back bitch, so I'm using Portainer. Like, I'm joking. I don't think people who use Portainer are bitch. It was just a joke. Chill. And Portainer, getting that set up is equally as easy. Go to the official Portainer website and it will give you deployment instructions. Just create a volume and then run one simple command. You can literally copy and paste both of those, run it, and Portainer will be set up and good to go. So to access Portainer, just go to your host name, followed by the port that you specified. For most recent builds, it uses 9443 and HTTPS. So make sure that you are following those steps or whatever you specified when you set up Portainer. And immediately you'll see that I'm running quite a few things over here. Let's go into my containers. So excluding Portainer, we have Jellyfin, an Nginx self-hosted website, Nginx Proxy Manager, Filebrowser, and Pihole. So we have quite a decent amount of things running on here. Now again, this is all about perspective. This isn't a massive home server that costs thousands of dollars and sucks up hundreds and hundreds of watts. This thing is using just under 5 watts when fully ramped up, and at idle sits around 1. So yeah, this is a very low powered machine. So these are the services I'm running, and honestly, it runs them fairly well. So if you're not familiar with Portainer, a reason why I like using it is because it uses Docker Compose by default, and I'm a fan of Docker Compose. I think it's easy to spin up stacks using Docker Compose, and the implementation in Portainer I just think is very user friendly. So the way you go about that is you go into app templates, and in here they already have some preloaded templates you can choose from. Now keep in mind that some of these don't natively support ARM-based systems right out of the box, so you may need to create your own custom templates and make sure that all the components are supported by ARM. You can check this by looking at the tags in the Docker image. So pretty much for all of mine, I have custom templates created. Let's start with Jellyfin. So we'll go in here to edit, and you can see my Jellyfin instance. And one thing you'll notice is down here in volumes, I have it mounted to a local mount, which is tied directly to my external storage. So I am using a really tiny little USB external storage SSD just to give me more than the 16 gigabytes on the SD card. You are free to add multiple terabytes if you want, but for this example, I wanted to keep it low power and small footprint. I'll just go back into my server and actually show you. So if we do an lsblk, you can see that we have this SDA1 partition. It is 120 gigabytes, and you can see the mount point is /mnt/portable. And if we go back to my Docker Compose YAML, you will see that the volumes I am passing through for Jellyfin to use as its media folder and config folder are in that same location: mount, portable, data, Jellyfin config, and then data, Jellyfin, data. So that simply means all I have to do is put any media into this data Jellyfin data folder, and it will be picked up by Jellyfin, and I can watch it on whatever device I want. So let's see it in action. So if we go back into the server, we'll just take a look at what's in there. It was in MNT, portable, data, and Jellyfin, and then data. You can see we have 2 movies, Inception and The Rock. Rest in peace, Sean Connery. So we should have 2 movies on Jellyfin to watch. Now I have gone through and deployed this. Obviously you saw that the container was running. You can see it is exposed to port 8096. So again, pi0.local port 8096. And you'll see here's our Jellyfin instance. And there's our movies. And Jellyfin is just like Plex in that it's used as a central media server to host your media so that you can watch it locally or remotely or wherever on whatever device you want. But Jellyfin is obviously free, and it is a bit more customizable. You can modify the entire GUI if you would like. I know there's a lot of templates out there for that, but I am just using the default one because, again, I'm a basic bitch. So yeah, let's pull it up on the phone and see how it works. Now again, this is a quad-core ARM-based 1 gigahertz processor on a device that's using about 2 watts of power. Keep that in mind. So obviously, you're not going to want this thing real-time transcoding your 1080p, 50 megabit footage, but over local network, it's perfectly fine. Okay, here we are in Jellyfin, and let's go ahead and pick up where we left off with Inception. Bada boom, it's playing. And while that is playing, let's go back into our server, hit top, so we can see how this is running and how it's handling it. And yeah, you can see we're using a good bit of our RAM, which isn't a big deal. We're using all of our swap and our processes. Let's look down here. It's not too bad. You can see Jellyfin is using about 23-24% of the CPU. And that's just one stream. Now, obviously, this is over the local network. It's not doing any real transcoding on it. But again, tiny CPU, low power. Very impressive. All right, let's move up the list. Nginx. So if you want to host your own Nginx website or service or whatever, you can simply spin up a Nginx Docker Compose YAML, which I don't have, meaning that I used the default one. So let's go into our app templates, go into Nginx, show advanced options, and here is where you can specify which ports you want to map to. By default, it uses 80 and 443. You can map those to whatever you want. It will pick them at random if you don't specify here. For your Nginx container, I would suggest leaving this as its default. And for your container that contains your website information, you can change this to whatever location your website is stored on. So in my case, I just threw an HTML file on my portable SSD. Let's go back there and you can see an example of that. Remember, we are in Mount, Portable, Data. And here you can see I have a file browser, a Jellyfin, an Nginx, and a photo prism. That was for testing purposes. That's a future video. But here we have our Nginx folder. So let's go into there and see what's in there. An HTML folder. Let's dive into there. And there's one file, index.html. Let's take a look at it. Wow, what an amazing website. You can make it as elaborate as you want if you have more experience with Nginx, but just to show you as an example, let's go back to our containers. Nginx, it is hosted, let's see, it is hosted on 49.176. Wow, beautiful. Self-hosted website. Put this on your resume. You'll be a Google in no time. Moving on, staying in the Nginx family, Nginx Reverse Proxy, one of the most popular services that a lot of people run to run a reverse proxy on their system, meaning that it's going to stand as a middleman between your services and the outside world so that you can bring in all your traffic and have it navigate through your reverse proxy and point to whatever services you want on your LAN. So yeah, for this, I again did my own custom template. Let's go take a look at it. And here you can see again, very simple, very easy to implement. So the only things I really changed were the default ports. Everything else is kind of left static. We can go take a look at our example. It is hosted on 40,080. We gotta go to the admin panel, which is apparently not on this one. Is it just that? I forget which one the admin panel's on. It must be on 4081. Found it. So here we are in Nginx Proxy Manager. I have an entire video dedicated to getting this set up. I will link that up here. I recommend checking that out if you want an easy to set up reverse proxy in your network. And honestly, it's really cool, so I recommend checking that out. But here you can see it runs on a Raspberry Pi 02 with no problems. We can go in here and add a proxy host if we want. taco.potato.com. Maybe we want that forwarding to a local IP of this over port 80. Sure, why not? Save. You have to press enter. Save. Just like that, we have a reverse proxy set up for tacopotato.com, forwarding directly to my local IP of 10.0.0.26 over port 80. Now there's no SSL on this yet. If you want to learn how to do that again, check out that video. But this just goes to show you how versatile this Pi 02 actually is. All right, FileBrowser. It is another service that I strongly recommend. It is easy to set up. It's lightweight. It is convenient. And it is what it says it is. It's a web-based file browser where you can store all the files you want and you can share them remotely with whoever you want. So again, go into your app templates and down to File Browser, which is a default option. You can name it whatever you want, but go into advanced options, and for data, just like with Jellyfin and others, change this to a binding mount and then specify a host location. So going back to our server, you will see that we have a file browser location, and let's take a look at what is in there. Data. So what is in there? A database.db, which houses all of the files. So this is going to be the location that we want to use. Now, obviously, I've set this up before, and if we go into our container, you will see that my data path is mounted directly to what we were just looking at, mount portable data, Filebrowser/data. So, all right, let's check it out. And just like that, we're in Filebrowser. Like I've said before, it's not the sexiest service or GUI that you've ever seen, but it gets the job done, and it's extremely straightforward to use. So you can create folders in here, and we can call this new folder. Boom, it puts you right into that folder. You can add a file, new file.txt, and just like that, it puts you in here. I can say, hello guys, subscribe to your favorite owl, Raid Owl. Save, boom, there's a file. You can also upload files. You can upload entire folders directly from your local machine. You can download whatever files, and a really cool feature is that you can share. So click on this little share icon. You can specify a time if you only want to share it for 5 seconds. If you want to share it for 1,000 days, you can specify that here. You can also specify a password on that. And then when you hit share, it's going to give you a link. You can copy that. The link is copied. You can now send that link out to whoever you want, assuming that you've opened this up to your WAN and you are using Nginx Proxy Manager or whatever reverse proxy. You can now share this with whoever in the world, and they can download and see whatever files you have shared in Filebrowser. And all of this is being stored on that tiny little portable external drive. So again, you can set up terabytes worth of data. You're not limited to a tiny 120 gigabyte SSD. So keep that in mind. All right, back to the last thing, and no Pi would be complete without setting up Pihole, right? Everybody and their mom, the first thing they do when they get a Raspberry Pi is set up Pihole. And if you haven't heard of Pihole, it's basically just a DNS server that you use to block incoming ads and set up custom DNS rules. So it's extremely lightweight. That's why it's so popular on the Raspberry Pi. And I don't have a dedicated video on this, but you can literally find thousands of videos on YouTube for setting up Pihole. So I have it running on here. I'm not gonna walk through the entire setup process. I will show you the template that I used. Here it is. I didn't change hardly anything here. The only thing I changed was the password, which obviously is not a real password, or is it? And then the ports you'd like to use. So again, this Raspberry Pi Zero is hosting quite a few things, and you are not limited to just this. As you saw when I ran the top command, we are not pinning this CPU by any stretch of the imagination. We still have a lot of headroom on this thing. So again, really powerful for what it is. So that was a tour of my Raspberry Pi Zero 2, world's smallest home server. What do you guys think? Let me know down in the comments. I think it handles everything pretty well. It's a decent amount of services. Obviously, I could throw more at it, but with the amount of computers I have around here, I don't quite need to throw more at it, but hey, you never know. Now, I know Raspberry Pi Zeros are extremely hard to get, both the original and the 2. Now, the 2 is much more powerful, and you still can do this with the original. This one is actually an original right here. I tested it on this, and it handled everything, but it just handled it much worse and slower. Now, it did run Jellyfin, but it was using quite a lot of CPU just for running that one service. So again, I know they're hard to get, so if this is all you can find, then feel free to go with that. If you can get your hands on a Raspberry Pi Zero 2, by all means, go for it. They are retailing at $15. Unless you find them at a retailer, you'll probably have to spend upwards of $30, maybe even $50 to snag one. But for what they are and the low power they consume and how versatile they are, they might be worth it depending on your budget, obviously. So let's jump into comment of the week. This one comes on my Chromebook to home server conversion video. So very similar to what I'm doing here. So if you have a Chromebook lying around that you want to turn into a home server, check that video out. But this comment comes from Gabe, who says, I like Portainer. I personally prefer the graphical screen because I know all the settings. With command lines, I sometimes miss certain things. I agree, Gabe. I like GUIs as well. I also like using the command line. It's not really an either or. You can pick whichever one you want. Now, so there's the stigma that if you're using the command line, that's the only way to get all the features you want. And if you're using a GUI, then you're a noob who doesn't know what they're doing and is kneecapping the software. But honestly, a lot of services put a lot of work into creating really functional GUIs that are extremely user-friendly. And you don't have to be some kind of crazy basement dwelling Linux nerd to want to spin up awesome services on your home server. So if you have to resort to using the GUI and you don't have the time to learn the CLI, then go for it. But that is it. I hope you found the video entertaining, maybe somewhat informative. I'd be interested to know what your lowest power home server device is in your entire setup. Can you beat the 3-ish watts on a Raspberry Pi Zero 2? Let me know down in the comments. But if you like this video, be sure to drop a like. If you like content like this, please consider subscribing. It helps a ton. We are almost at 15,000 subscribers, which is absolutely freaking bananas. I can't believe it. And I want to give a huge shout out to all my YouTube channel supporters and Patreons, or members, YouTube members and Patreons. You guys are awesome. You are all listed right here-ish somewhere. You guys are the freaking best. But that is it. If you got this far in the video, I sincerely appreciate it. Thank you so much for watching, and I will see you in the next one.